Welcome to Success Life class. Welcome to Success Life class. We're kicking off. We're kicking off. We're kicking off. Please share the link to your colleagues. Let them join. Share the link. As soon as you join, please share the link. Don't be stingy. Share the link. Please. The more we are, the better. Iron sharpeneth iron. Welcome to Success Life class. We are live. 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 Welcome. Mercy, active. Yes, the first person today. Mercy. As soon as you come in, please drop your comments. Register your presence by your attendance. So just say the word active. Also like our video. Just click the like button. Click the like button. Click the like button. Welcome. 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 We're starting. We're starting. We're starting. Get ready. Get ready. Get ready. We're starting. Yes, we have 4 people live now. 4. Well done. Well done. Share the link. Please share the link everywhere. Share the link. All your one groups. Please share the link. Share the link. Share the link. Yes. Welcome. Welcome. We are now 6 years. Welcome. 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 Welcome, welcome, welcome. We are now 6. Welcome. As soon as you come in, please hit the like button. Drop your comment. Hey, Michael, you're welcome. Michael, you're welcome. Yes. Welcome, welcome, welcome. Welcome, welcome, welcome. Welcome, 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 welcome. Yes, we are now 8. Yes, 8 people on live, 5 likes. Please, if you're just coming in, hit the like button. Hit the like button. You're welcome. Also, share the link to your colleagues. Share the links to your colleagues, please, so that others can join. Let's encourage each other. Let's be our brother's keeper. Yes, 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 yes. Welcome, I welcome. Yes, you are welcome. DM money, you are welcome. I welcome. Yes, you are welcome. Welcome, 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 welcome. How many are we now? We are now 9. Yes, 9 people are active. Yes, K-Lines, you are welcome. What are we learning today? We are learning physics today. Also today, we are fixing our timetable for our online class so that we're not just doing only physics. We are fixing our timetable this night so that you know what we're having every day. The day we're having math, the day we're having other courses. You understand? Yes, yes, we are now 12. We are now 12. We are now 12. We are now 12. Yes, yes, yes. Someone said that's good. Yes, that's very okay. Yes, yes. We are doing our timetable today. So we can also be learning other courses. Good. We are now 15. We are now 15. Well done. Those that are sharing the link, well done. God bless you. Well done. Those sharing the link to their different groups, well done, well done, well done. You are the reason why this class will keep holding. Well done. Well done, well done. Those sharing the link, well done. We are now 15 on the group. Well done, well done. Good. 19. Good. DM says sharing the link. Thank you. DM Money for sharing the link. Thank you for sharing the link. Well done. Well done, everybody. Those sharing the link, well done. Good evening, Sir Emmanuel. Well done. Yes. Well done, everybody. Well done. We are now 19. We are now 19. Once we are 30, we'll start. Once we are 30, we'll start. So I'm active. I'm active. I'm online. I'm active. I'm active. As you're coming in, please hit the like button. Hit the like button. Hit the like button. Please put your phone on DND. Don't forget what I told you in class today. Put your phone on DND. Put your phone on DND. So no distraction, no distraction. Close all your social media for now. Close all your social media for now. We are 24 now. Sharp, sharp, sharp. Sharp, 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 sharp. Sharp, sharp, sharp. Welcome everybody, welcome everybody, welcome everybody, welcome everybody. Today we're looking at physics 101. Physics 101. Please keep sharing the link. Keep sharing the link. Keep sharing the link. If today is your first time of joining our live class, can I see your comments? Drop a comment. It's my first time. Let's welcome you. Let's welcome you. If it's your first time of joining our live class, drop a comment. It's my first time. Let's welcome you. Let me know our special first timers. So this is the first time of joining. Oh, Cleaner says my first. Zina said it's my first time. You're welcome, Zina. Zina, you're welcome. First timers, you're welcome. Please, everybody, let's welcome the first timers. Let's welcome the first timers. Zina, you're welcome. You're welcome. You're welcome. Good to have you here. Good to have you here. Any other first timer? Any other first person that just started today? You are welcome. You're welcome. You're welcome. Okay, Zina said thanks. Yes, yes. Please keep sharing. Zina, share the link for us. Share the link. Keep sharing the link. Keep sharing. Okay, Demon, you say you're also new. Welcome, welcome, welcome. Keep sharing the link. Well done. Those sharing the link. Well done, well done. Keep sharing the link, please. Keep sharing the link. Once we are 30, we start. We are now 26. Please, if you have joined off all your other social media so you can be focused, get your writing material. This is a serious class. Treat it like a normal lecture, please. Treat it like a normal lecture. Off all your social media so there will be no distraction. Put your phone on DND. Get your writing materials. Make sure you're seated where you can concentrate. Oh, Onyin says my first time too. You're welcome. Onyin me and maybe you're welcome. You're welcome. Everybody, please let's welcome her. Let's welcome he or she. I don't know if it's he or she, but welcome. You're welcome. You're welcome. You're welcome. You're welcome. We have not yet hit 30. What's going on, guys? What's going on, guys? Keep sharing the link. We have not hit 30 yet. Let's get to 30 then start. We are 26 now. Keep sharing the link. Keep sharing the link. Keep sharing the link. You're welcome, you're welcome, you're welcome. Yes, 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 yes. We are 29. Well done, guys. Well done. Those sharing the link, well done. We are now 29. Well done. Just one more and we'll start. One more person to join us and we'll start. Keep sharing the link. Keep sharing the link. Well done, guys. Well done. Share to all your one groups you are in. Just share the link. Let them join. Yes, yes. Yes, we are 31. Excellent, 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 excellent. Please hit the like button. Let us start. We are welcome now. We can start. This number has given me the go ahead to start. Others can join us. Let us start. Welcome, everybody. Please, we have started, so no going back now. We have started. So one more comment and we'll start. Just say, sir, we are already active. Let me see if you're active. Say, sir, active. Sir, go ahead. Sir, go ahead. Drop your last comment, then let's go. Let me go to the board. Drop your last comment. Let me go to the board. Drop your last comment. Let me go to the board. If you are active, say active, sir. Yes. Messi said active. Messi Bamdele say active. Good. Please, I want to see more active. Yes, more active. Yes. Zina said active. Nice, nice, nice. Active. Okay, I can go to the board. Excellent. Active. Emmanuel said active. Juliana said active. Good. Michael active. David active. Ayobami active. Oh, this is very good. Alex wrote to me. I like the engagement today. This is good. This is good. Yes. Peculiar active. Megan active. I like what I'm saying. This is very, very good. 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 Peculiar said active. Megan said active. Very good. Very good. Very good. Okay, let's go and start. Let's go and start. Let's go and start. So today the topic we're treating today I want to treat a topic called momentum and collision. I want to treat momentum and collision. Momentum and collision today. Momentum and what? Collision in physics. Momentum and collision. You can't write physics exam and you don't see question on that momentum and collision. You cannot write physics exam and you don't see question on momentum and collision. Momentum and collision. Momentum and collision. Today we're looking at what? Momentum and collision. That specific topic. Momentum and what? Collision. Momentum and collision. Momentum and what? And collision. Class. Of course, we know that momentum, the formula for momentum, P. The symbol for momentum in physics is P. Momentum is mass of a body times the velocity of the body. The momentum a body experiences in physics is called the mass of the body is the product of the mass and the velocity. So momentum is mass times velocity. Mass times velocity. At the end of this class, I'll set our online class timetable. I'll set our online class timetable. At the end of this class, I'll set our online class timetable. So you know what we're having every day. You know what we're having every day. I'll set the timetable for physics and mathematics. Sadelzi will now set his own for chemistry. I don't know when he will do his own, but I will ask him. He will set his own for chemistry. But I'm handling physics and the two mathematics, right? I'll set the timetable for the physics and the two mathematics. So we are running with that already. I'll ask Delzi when it's comfortable for him to teach chemistry. Are we together? Yes, but I cannot control when he wants to fix chemistry. I cannot fix a day that he might not like. So that will be on him to fix a day for chemistry. Are we together? I'm handling physics and mathematics, and I'll fix the days for the class for physics and mathematics. Those of you on the chemistry, Delzi chemistry group, you can always be asking us, please, when is the day for our chemistry? Are we together? Yes. Now moving forward. So after I finish teaching, I will set the timetable. Also, we will not be wasting much time because now that school has resumed, people will be so busy, right? People will be so tired after classes. So anytime I come live, I will not even waste that 5 minutes. Be saying, welcome. Don't let me ginger you. Let it be a normal thing. Maybe I have to ginger you before you be serious, but it's you that pays school fees. Do you get? Let it be that we just come in. I'll just welcome you. I just welcome you for the first 2-3 minutes. That's all. And I'll start teaching. So that 1 hour we can all go and sleep because we have lecture the next day. 1 hour we are done. Go and sleep. Let it just be 1 hour class. For me to admit, I must have been working throughout the whole day, so I must be tired. So 1 hour I do my thing and I go my way. Everybody goes their way. You know we are gaining something every day. Do you understand? So please don't wait for someone to come and cajole you, be begging, welcome, or be gingering you. Just know that this thing is working every day. We have the timetable, we work with it. So my physics and math means for my own session, we're doing it 3 days a week because 1 day for physics, 1 day for physics, 1 day for math 110, another day for math 120. I can just put 1 more day for anything assignment for the week, assignment or problems for the week. Assignments or problems for the week, and I'm done. Then there's we have 7 days in a week, right? Just give me 3 days. In fact, these 3 days. Then any other day I can just put any bonus. Just give you this bonus day for anything assignment for the week, so that I will not be doing assignment when we are supposed to be learning. Are we together? So this last day will be bonus, just assignment day. We can do it weekend. So we're going to clear our assignment for the previous week. Any problem of the previous week, so this practical thing is stopping us. So this assignment, this. We'll just use maybe Saturday. But these 3 days will be during the week. So Monday is definitely physics. Please, let me just set it now so we'll not waste time because there's no time. Tomorrow you have lecture, right? Monday is physics. So write down the timetable. Monday, online class timetable. Monday is physics. I'll be doing it in such a way that the days we're having normal tutorial class, don't be having these courses too. When do we have Math 120 on Wednesday? Wednesday is Math 120. Wednesday is Math 120. When do we usually have Math 110? It's Thursday. So Thursday is Math 110. Saturday or Sunday, one of these days, Saturday or Sunday will be assignment review for the last week. Anything assignment review for the last week. Did they give any assignment in physics? Did they give any assignment in mathematics? Saturday or Sunday, we'll pick 1 day. Please let me see your comment. What did you prefer for assignment review, Saturday or Sunday? What did you prefer for assignment review, Saturday or Sunday? Drop your comment. Oh, good. We are 44 now. We are 44. Those of you that just joined when I was teaching, welcome. Drop your comment. What did you prefer for assignment review? Oh, Mercy says Saturday. Victoria says Saturday. Welcome. Everybody, Zina says Saturday. Okay. Michael says Saturday. Tina says Saturday. Okay, that's good. So you can be able to write it and report the assignment on Sunday. Rabbi, so submit on Monday. This is good. This will be good. Everybody's saying Saturday. But do you like the timetable idea? Do you all like the timetable idea? Someone say what of practical? Of course, that Saturday. Anything assignment practical, anything practical questions, whatever, is that Saturday. Okay, someone says Sunday because we're busy on Saturday. One person has said Sunday. Why are you busy on Saturday? It's not in the morning, it's in the night. Oh, Saturday night. Please, let's see your comment. We'll go with the majority. Someone says Sunday or Monday for submission of assignments. Okay. Saturday, most people are saying Saturday. We'll go with the majority. Please drop your comments now. Some of you, as you're in this live, make sure you are contributing to what will favor you. Talk your mind now. Don't let them decide for you. Because someone is going to say Monday. Which one will be Monday again? So if you don't talk your mind, someone will go and decide one wrong day that does not favor you. So talk your mind. Most people are saying Saturday. Saturday is the most convenient. Yes. So please, the topics taught online, are they the same with the physical class? Obviously, yes. But of course, they are the same, yes. But Also, please take note. Okay, I will address something soon. I will address something soon. Most people are saying Saturday, Saturday, Saturday. Okay, most people are saying, peculiar say yes, timetable preferred. So the timetable is okay, right? If you notice, those in our physical class say that the timetable rhymes with what we usually have in our physical class. Like Monday today we did physics, so I'm doing physics today. Wednesday is Math 120, so we are doing Math 120 online. Thursday is Math 110, we are doing Math 110 online. You see, it makes sense, right? Yeah, someone says Saturday is better for review. Emmanuel Chukwueta says Saturday is better for review. Good. So whatever assignment, whether it's chemistry, whether it's physics, whether it's maths, we use Saturday to be doing assignment. Mean that you don't send me assignment during the week, please. Let it be on Saturday. Although if you send me during the week, I will gather it and save it so that Saturday I will do it. Okay. Tita said timetable is the timetable is okay. The timetable is okay. Yes. So it means that chemistry can come in either on Tuesday or on Friday. I will ask Delzy. Chemistry can come in either on Tuesday or on Friday. This is good. This is good. This is good. Okay. So someone asked a very important question I want to address now. The question the person asked is, please, is this the same as the physical class? It's going to be the same quality, but of course, please, if you've not paid us for this online class, you notice I made it open to everybody. But please, even if you as a woman may tell yourself the truth, it will be difficult for someone to come teaching you every day in the night, standing for 1 hour every night till exam. If you do not support the person with a little payment, this is out of school now. School is not the one paying us for this. So there are some of our students that have registered with us. Good. Please, you've not registered. Don't wait till someone come and cajole you. Even you, a human being, have small conscience. I like what some students do. They've already messaged me, even if I've not said anything. Sir, you're trying how much? Let us, it's even me, I have an uncle or a brother like you. I'm not going to be doing this for nothing. It's every night. Do together. Some of you just use your own conscience. Everything is not about say this, that. Do you understand? Ask please, how much is your class? I like it. Let me join this class. Are we together? This one doesn't have any limit because whether we're busy during the day, they are being taught every night. This is how you plan for your education. After spending school fees, spending the big money, and this is your security to make sure you come out well, you've got a good result. So this is also important. So as you're paying for your player, you're spending for this, you're paying for that, you're paying for where they will teach you how to learn very well. Some of you are in the math class today, you saw that it was very confusing. You were in your math class, I guess I got some DMs. People say they are lost, they don't understand what's going on. Are we together? So please, very soon this live class will be locked and exclusive to only those that have registered. This is not a first time of doing this kind of class. We know how we will do it. I have a list of people that have paid me. I know how to send them a private link. Only them will be joining the class. But for now, I'm just trying to show you the quality, the need, why you need this class. That's why I'm opening it to everybody. You can see you really need a class like this. So don't wait for someone to come and cajole you. Send me a DM. So that's how you go be. I like this class. This is a good idea. I know someone that is working offshore. He doesn't even have time to come for your lectures. He just paid immediately. He says, I like this class. Don't worry. Don't even talk too much. He paid even more. Do you understand? When you see something that is good for you, tell yourself, this thing is good, this thing what and it did good. Are we together? I'm talking to you as a fellow, we are together. Are we together? So please send me a message. You know you've not registered for our class. 081 824 24350. Show us small love, Show us small love. Just a little support so that they try. You put yourself in the person's shoe, standing every night teaching. Do you understand? So, you've not registered with us. Look, please, I have been following your class. I just joined today, but I would like to know more about the payment. Send me that WhatsApp message. Even as you're watching us, send me that WhatsApp message. Just be little conscious. Say, no, let me just, this is the right thing to do. Even if I have money, let me just ask first. Let me make inquiries. Let me try. Let me put effort. We also allow instrumental payments, bit by bit payment. You don't have everything at once. We allow bit by bit payments. Are we together? Yes. You can say, okay, I'll be giving you this and this per month. I will add you. So please, I'm doing my plan, so a lot of expenses now. Can I be paying you small per month? Yes, I can. Since it's still, exam is by March. And so you say, okay, before exam, at least you'll be seeing me in your class now. If I don't pay, you remove me, but I'll pay. Do you understand? We can come to an arrangement. Are we together? So that's that for that. So these are timetable. You see that it's a serious class. We have a timetable. So it's a very serious class. It's not a joking class. Are we together? It's a very serious. So you see, we have a timetable now. We're working with this. So it means that for me, I'm coming next on Wednesday. I don't have class for you tomorrow. My own teaching is coming next on Wednesday, March 120. Don't miss this one. This is further maths. You will enjoy me in this live class a lot. Further maths. This Thursday is March 110. This Thursday is March 110. Thursday is March 110. Thursday, March 110. Don't miss it. Thursday, March 110. Then Saturday, I'll be doing all your assignments for you. So please, show us small love. Show us small love. Those that have registered, you have no problem. You have registered, right? I have I have registered members group. Those that have not registered, please. You can see how someone is planning your academics for you. You can see how someone is planning your academics for you. You should support the person. Say, sir, you try. It's not easy. I'm not related to you, so why should I don't owe me this, but you're doing this for us. So please take this one, support us. You understand? School is not paying us for this. Okay, let's go to the solve teaching now. So today I want to quickly teach momentum and collision so you can go and sleep and prepare for class tomorrow. We'll not waste time. I told you we'll not be wasting time so you can rest. 1 hour we are done, or 30 minutes we are done. Yes, now, momentum and collision class. I said momentum is the mass, product of the mass of the body times the what? Velocity of the body. Now, there are two types of momentum actually. You have your initial momentum and you have your final momentum. Class, when you use mass times final velocity, what you have is your final momentum. When you use mass times initial velocity, what you have is the initial momentum. So we have your final momentum and we have your initial momentum. I hope everybody can actually hear me well. I hope you can all hear me well, please. Hope you can hear me well. Hope you can hear me well, class. Okay, they say yes, we can hear you. Zina said yes, we can hear you. Good. I like this set. I like the way you're engaging. Everybody's engaging. Well done. Nobody's just dulling. Everybody's engaging. Michael said yes. Messi said yes. Sitan said not that much. Are you sure it's not your network? Sir, please, can we download the video after now? Yes, you can download it after now. If you go to my channel, you can download it. Sir, we can hear you. Yes. Emmanuel Covenant said yes, we can hear you. Sir, yes, loud and clear. Ebuka said loud and clear. Thank you for engaging. Those of you that keep engaging, you're the one encouraging us. Thank you. It's not easy. All of you that keep dropping your comments, engaging, sir, well done. You don't know how much that means to us. Thank you very much. Thank you. Peculiar said right on. Thank you. Delight said, sir, we can hear you. Thank you. Those that keep dropping comments, thank you. Thank you for engaging us. Yes. Peculiar said right on. Yes. Please, if you're also watching this class and you have not subscribed to our channel, use the button to hit the subscribe button. So anytime we come on live, you will know. If you have subscribed to our channel, it will easily notify you I'm online for any class. Do you understand? Hit the subscribe button before you forget. Some of you have been attending our club, you have not subscribed. Hit the subscribe button. You see the subscribe button below there. Hit it so that you have joined our channel. You're not paying for it. Just hit the subscribe button. Like, follow us on YouTube. You understand? Hit the subscribe button. Now let's go. So I said we have final momentum and we have initial momentum. The final momentum is mass times final velocity V. Initial momentum is mass times initial velocity U. So class, that's the momentum aspect. Now talking about collision. I already hinted this in class. I said we have three types of collision in physics. We have the elastic collision. We have the inelastic collision. And we have the perfectly elastic collision. We have the elastic collision, the inelastic collision, and the perfectly elastic collision. But our focus will be on these two class. This third type of collision is not going to be, we're not going to do a calculation on this third part. For the physics aspect, we're going to focus on these two, the elastic and inelastic collision. Now class, what does it mean for two bodies? Can I clean this number now? So those that want to message us, sir, how is the payment like? Save the number, this is my number. Message us, sir, please, I want to let's support you. How much? How can we join the class? I want to join your class. I want to join this online class full time. I might not even have time for physical class, but I will join this online one very well. Message us. Now, class. So as I said, it's important that you know that there are three types of collision, but our focus will be on these two class. Elastic and inelastic collision. Elastic and inelastic collision. Class, one thing you should know is that we have two bodies, body A and body B. And then they are colliding. There are different possible things that could happen. Class, for two bodies to collide, it means that at least one of the body must be moving. For two bodies to collide, at least one of the bodies must be moving. For two bodies to collide, at least one of the bodies must be moving. Are we together? Now, before the collision occurs, the two bodies have their masses. Let's call this body mass of this body MA, or let's call this body 1 and body 2. first body and second body. So let's call this M1 and let's call this M. So the two bodies have their different masses, M1 and M2. The two bodies have their different masses, M1 and M2. Now, another thing you should know again is that the two bodies have their velocity, initial velocity U1 and U2. Let the velocity of this body be U1 and let the velocity of this body be U2. Now, you know the funny thing? This is before collision. Before what? Collision. Now, after collision, so this is before collision. After collision, these two bodies' masses, class. Collision does not affect the mass of a body, it only affects the velocity, the speed of a body. Take note. Because you collided with someone doesn't mean that you weigh less or you weigh more. Your mass does not change. So the mass M1 is still there, M1, and there's still M2. But class, instead of, if you notice, before collision, we use U to represent initial velocity. So we use U to represent the velocity of the two bodies before collision. U1 means the initial velocity of the first body. U2 means the initial velocity of the second body. But after collision, class, the velocities now change to V1 and V2, final velocity. Final velocity, V1 and what? V2. So class, the question we need to ask ourselves now is momentum conserved. There's what we call law of conservation of linear momentum in physics. The law of conservation of linear momentum in what? Physics. This was an A course for me when I was in year 1. This was an A course. That's why it's very easy. I can just break it down easily. I made an A in the course. So you can't give what you don't have. So the person teaching you here made A's in most of his courses. I never got to C in my year 1. I never got to C in my year 1. So when anything I say, please follow it because I've made A myself and I've made many students get A in this course. Now follow me as I was saying. Before collision, after collision. So before collision, the bodies are moving, they have their masses and they have their initial velocity U1 and U2. After collision, they still have their masses, but their velocity have changed. The masses still M1 and M2, but their velocity have changed to final velocity V1 and V2. Class, what happens after collision will determine whether a collision is elastic or inelastic. What happens after the bodies have collided will determine whether a collision is elastic or inelastic. Now get your writing materials and write down. Get your writing materials and write down. Write down. Are you ready? Collision. Write down collision. Collision. Are we together? Collision is a phenomenon which has these features. Collision is a phenomenon which has these features. Collision is a phenomenon which has these features. I hope you can hear me clearly. Let me come close to this. I'm dictating now. Let me come closer. Collision. Oh, good. We have 50 people live. Well done. Welcome. Welcome. We have 50 students live. Welcome. 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 Collision is a phenomenon which has three features. Collision is a phenomenon which has three features. I'm coming closer to the phone so that everybody can hear me. I'm dictating. Please, can you hear me clearly? My dictation. Please drop a comment. I want to continue dictating now. If I write, I'll be slower and we don't have time. Can you hear my dictation very clearly? Collision is a phenomenon which has three features. Someone should let me know in the comments. Can you hear what I'm dictating very clearly? One. Okay. Zina said yes, sir. You can hear me clearly. Good. Delight said yes, sir. Okay, good. So if I'm writing, I will take more time. I have to not be writing and be cleaning, but writing and be cleaning. But in normal physical class, I dictate sometimes, right? So I want to also dictate. So I'm closer to the phone now. That's why you're not seeing me on the board, so that you can hear me very well. Everybody can hear me. Thank God. There's no negative comments. So if everybody said they can hear me. Okay, let me continue. Collision is a phenomenon which has three features. You can see clearly that with this online class, you cover your syllabus very early before exam even reach. You have covered your syllabus. You can even go again. You can cover each course two times. You see the speed we are going at. We're in collision now. Collision is a phenomenon which has three features. A, it occurs in a short interval. Peculiar said very clear. Good. That means you can hear me very clearly. Oh, I'm very happy. We are now 56. We are now 56 on live. Well done, class. Well done, class. Collision is a phenomenon which has three features. A, it occurs in a short time interval. A, it occurs in a short time interval. A, it occurs in a short time interval. B, what happens after collision differs from what happens before collision. What happens after collision differs from what happens before collision. C. The colliding bodies may be assumed. The colliding bodies may be assumed to constitute a closed system. The colliding bodies may be assumed to constitute a closed system. D. Momentum and energy may be conserved during collision. Momentum and energy may be conserved during collision. Take the time and write it. These are the four features of what? Of collision. These are the four features of collision. Momentum and energy may be conserved during collision. Okay, Lawrence said clear. Lawrence Prince, we said clear. Yes, Titan said very clear, sir. Uzoma, I'm just going through your comments while you're writing on the board. Emmanuel said very clear. Good. Loud and clear, sir. Good. I'm very happy. So no excuse. It seems we are all back from the village. So nobody's complaining of network again. This is very good. You know, during the holiday when we were learning, people were saying, sir, it's blurry. Thank God we are all back. Hey, finally. Once you're done writing words on the board, let me know so I can continue. Okay, Zina said, sir, writing is taking our time. Oh, hey, that's why I said, hey. Marvelous says, sir, no data, I'll be fast. Okay. Oh, yeah, let me go. So are you done writing words on the board? Let me know in the comment section. Are you done writing? Can I clean the board? Peculiar says, stop writing. Okay, I'll stop writing. Yes, you are the boss. You are the boss. Peculiar says, stop writing. I'll stop writing. You are done writing words on the board? Okay, let me clean the board. So before I clean the board, let me explain what's on the board. It occurs in a short time interval. What happens after collision differs from what happens before collision. The colliding bodies may be assumed to constitute a closed system, and momentum and energy may be conserved during collision. These are the four things you should know that is true about collision. Now I can clean the board now. So moving forward, the next thing we need to look at now, class, is write down types of collision. Types of collision. They say I should stop writing, but I need to write when I'm explaining some things. So I'll not write the subheading, but I will not write the full. I will dictate the others. Types of collision. So one, let us start with what? Elastic collision. Write down elastic collision. Let's explain what is elastic collision. Let us explain what is elastic collision. So I'm dictating now. Are we ready? Elastic collision. Can I start dictating? Elastic collision. Elastic collision. Elastic collision. Are you there? Elastic collision. Elastic collision. Elastic collision. A collision is defined as elastic. Yeah, someone said, Bossa, you said he has 3 features, but you wrote 4. The 4th one is just like a bonus. The 4th one is just like a bonus. The 4th one is a bonus, eh? The 4th one is just like a bonus. It's just like a bonus. So let's go. Let me dictate. So you can be seeing my but when I go back to board, I'll go back to the board. A collision is defined as elastic. If the total kinetic energy after collision A collision is defined as elastic if the total kinetic energy after collision is equal to that before collision, is equal to that before collision. If the total kinetic energy after collision is equal to that before collision. If the total kinetic energy after collision is equal to that before collision. Therefore, kinetic energy, linear momentum, and energy are conserved. Therefore, kinetic energy, linear momentum, and energy are conserved. Therefore, kinetic energy, linear momentum, and energy are conserved. Therefore, kinetic energy, linear momentum, and energy are conserved. Please note that. Therefore, kinetic energy, linear momentum, and energy are what? Are conserved. Also note, for elastic collision to occur, the two colliding bodies do not stick together after collision. The two colliding bodies do not stick together after collision. For elastic collision to occur, the two colliding bodies do not stick together after collision. For elastic collision to occur, the two colliding bodies do not stick together after collision. For elastic collision to occur, the two colliding bodies do not stick together after collision. Class, yes, because after collision, what happens? Do they stick together? Do they go together, or do they go their separate ways? After collision, for elastic collision to occur, the two colliding bodies do not stick together after collision. Are we together? The two colliding bodies do not stick together after collision. Now, there's one more thing very important. It's called coefficient of restitution. Coefficient of restitution. Class, for a elastic collision, the coefficient of restitution is 1. For elastic collision, the coefficient of restitution is 1. For elastic collision, the coefficient of restitution is 1. For elastic collision, the coefficient of restitution is 1. For elastic collision, the coefficient of restitution is what? Is 1. I will define coefficient of restitution soon. I will define what is coefficient of restitution. Oh, Christian said, what's the topic? The topic is momentum and collision. The topic is momentum and what? Collision. Welcome, Christian. Welcome, Christian. Welcome, Christian. Now, can we go to inelastic collision now? Please, let me see if you're still following. Yes, good luck. Say yes, sir. Very clear. Good. I'm happy. I'm happy. When you guys are encouraging us like this is good. Thank you. Thank you. Thank you. Thank you. Thank you. Christian say yes. Yes. Thank you. Yes. Yes. Okay, let's go to inelastic collision. Inelastic collision. So, class, if you notice, for elastic collision, the two bodies do not stick together, right? If they don't stick together, it means that they move away from each other with with different velocities. For elastic collision, the two bodies move away from each other with different velocities. For elastic collision, the two bodies move away from each other with different velocities. For elastic collision, the two bodies move away from each other with what? Different velocities. That's for what? Elastic collision. And what did I say? The coefficient of restriction is what? Is 1. Now write down inelastic collision. Inelastic collision. Thank you, thank you. Or Sadibe said, keep up the good work, sir. Thank you for the encouragement. It's very important. You will not understand because sometimes this, to keep like pushing in the same, it's not easy. Yeah, let's continue. For inelastic collision, let's go. For inelastic collision, the two colliding bodies stick together after collision. Thank you, Peculiar. The two colliding bodies stick together after collision with a common velocity. For inelastic collision, the two colliding bodies stick together with a common velocity. For inelastic collision, the two colliding bodies stick together with a common velocity. For inelastic collision, the two colliding bodies stick together with a common velocity. So, inelastic, they stick together. In elastic, what happens? The first one we did in elastic, what happens? They don't stick together, they go their separate ways. Class, don't forget, what did we say about elastic collision? What and what are conserved? Kinetic energy is conserved, linear momentum is conserved, and normal energy is also conserved. Please take note, this to ask in the exam for what? Elastic. The first one we did elastic. We said kinetic energy is conserved, linear momentum is conserved, and energy is also conserved. That's for what? elastic collision. Let us look at what is conserved in inelastic collision. What and what are conserved in inelastic collision. Are we ready? For inelastic condition, note that kinetic energy is not conserved. For inelastic collision, note that kinetic energy is not conserved. For inelastic collision, note kinetic energy is not conserved. For inelastic collision, note that kinetic energy is not conserved. Only momentum is conserved. For inelastic collision, note that kinetic energy is not conserved. Only momentum is conserved. For inelastic collision, note that kinetic energy is not conserved. Only what? Momentum is conserved. Now, what's the coefficient of restriction for inelastic collision? If you remember, I want to ask you a question. What is the coefficient of restriction for elastic collision we just did? Drop your comment in the comment section. What did I say is the coefficient of restriction for elastic collision? Let me drop your comment in the comment section. Drop your comment in the comment section. Let me see. Let me see if you are following. If you remember. Good. Zena said, well, I like this Zena. This Zena is just, she's always active. I don't know if it's he or she. Messi is our second active student is Messi after Zena. Megan is our third active student. Then Delight. They are always responding the first. And then I think Michael, but I don't know if Michael is still. Michael Obirisike and Pekulia. Yes, he has responded. You see, look at Michael. You, Mary, good. They are always responding immediately. That's very good. Reinhard Prince also, well done. Zena, well done. And Mechi Decency also, yes. Always responding very fast. Yes. Uzoma Michael is 1. Good. Good luck said is 1. Alex wrote to me is 1. David said is 1. Yes. Lawrence Prince will say my data is finished. Say Briley Ogene 1. Yes. So the question of restriction for elastic collision is what? 1. Now, what is the coefficient of restriction for inelastic collision? I want you to think. So can someone guess what is the coefficient of restriction for inelastic collision? Drop your comment. What should you think it should be? What do you think it should be for inelastic? If elastic is 1, what do you think the coefficient of restriction for inelastic is? Peculiar said 3. Well done, Peculiar. Kalinek said 1. Messi Bamdili said 0. Zina said 0. David Nseobong, well done, said 0. Peculiar said 0. Christian said -1. Michael said 0. Good luck said 2. Emmanuel Genesis said 0. Next Gen said 0. Who else is there? Mweze Mirabel said 0. Mweze Mirabel said 0. Class, the zeros have it. Actually, the coefficient of restitution for inelastic collision is 0. Alex wrote to me, well done, 0. I don't know whether I'm making the sense it says 0 or 2. Brill said less than 1. It is 0. For inelastic collision, the coefficient of restriction is what? Is 0. And don't forget, only what? Only momentum is conserved. Kinetic energy is not conserved. But in elastic collision, for the first one, elastic collision, both kinetic energy and linear momentum are what? Are conserved. Please take note. Now, the next thing we need to look at now. Write down Newton's law of restitution. Newton's law of what? Restitution. Are you ready? Newton's law of restitution. I hope you're enjoying I'm dictating, right? It's faster than writing. If I was writing, I wouldn't have gotten to this point, right? Class, the dictation is better, right? Then when I want to teach, I'll now go to the board and explain. It makes sense. It makes it also more interactive. So you're seeing the person that is talking to you. I think that's better, yes. I think I should have been doing this since. Because since sometimes when I want to talk to you, I will not be seeing my face. I will just be talking into the phone. But I think it's good if you are so that yes. Okay, someone said, please, sir, please throw a little more light on that. I'll still throw a little more light. I'm still dictating. I'll go to the board and explain everything. Don't worry yourself, eh? For now, we're just giving you notes. I'll go to the board and explain everything. Yes. So let's go to Newton's law of restitution. Are you writing? Hope you're writing material. Newton's law of restitution helps to explain, write down. Newton's law of restitution helps to explain the relationship. Newton's law of restitution helps to explain the relationship between the velocities. Newton's law of restitution helps to explain the relationship between the velocities after collision, V1 and V2. Newton's law of restitution helps to explain the velocities. The relationship, sorry. Newton's law of restitution helps to explain the relationship between the velocities after collision, V1 and V2, of the two colliding bodies. Newton's law of restitution helps to explain the relationship between the velocities after collision, V1 and V2, of the two colliding bodies. Newton's law of restitution helps to explain the relationship between the velocities after the collision, V1 and V2, of the two colliding bodies. of the two colliding bodies, and their velocities u1 and u2, and their velocities u1 and u2 before collision, and their velocities u1 and u2 before collision, and their velocities u1 and u2 before collision, and their velocities u1 and u2 before collision. So that's what Newton's law of restriction helps to determine. And class, the constant that was derived by Newton's law of restriction is called the coefficient of restitution. That coefficient of restriction I talked about, it was Newton's law of restriction that brought about that. It was Newton's law of restitution that brought about the coefficient of restitution. It was Newton's law of restitution that brought about the coefficient of what? Of restitution. So class, let's go to the board now. Let's go to the board. Are we ready? Let's go to the board quickly. Now, so class, note, when two bodies collide, the relative velocity, after collision is equal to minus E multiplied by relative velocity before collision. When two bodies collide, the relative velocity after collision is equal to minus E multiplied by relative velocity before collision. When two bodies collide, the relative velocity after collision is equal to minus E multiplied by relative velocity before collision. Where this E represents the coefficient of restitution. E represents the coefficient of restitution. E represents the coefficient of what? Restitution. E represents the coefficient of what? Restitution. So it means that minus E equals to V1 minus V2 all over U1 minus U2. Minus E equals to V1 minus V2 all over U1 minus U2. What is V1? Don't forget that diagram I showed you when we started this class. Let me remind you. It will help you to understand what is V1, V2, U1, U2. Remember that there are two bodies, body 1 and body 2, right? Before collision, this is before. So body 1 has an initial velocity U1, body 2 has an initial velocity U. After collision, what happens? Body 1 and body 2 again. This time around is V1 and V2. We use U before collision, we use V after collision. We use U for velocity before collision, and we use V for velocity after. So what this means that initial U1 means initial velocity of the first body, U2 means initial velocity of the second body, V1 means final velocity of the first body after collision, V2 means final velocity of the second body after collision. That's what all these people mean. And E means what? The coefficient of restitution. Don't forget again that for inelastic collision, the coefficient of restitution is 0. For elastic collision, coefficient of restriction is what? Is 1. If you are done writing this, we'll then go to law of conservation of linear momentum. Law of conservation of linear momentum. If you are done writing this, we are going to go to law of conservation of linear momentum. Law of conservation, well done. We still have 53 people on the class, 54 live, and they are active, they are writing. Well done, well done. It means we have resumed back. Well done, class. It means everybody has resumed back. We have all resumed back. Well done, well done, well done. If you're done writing on the board, let me know so I can continue dictating. I want to go to law of conservation of linear momentum. If you're done writing what is on the board, let me know so I can continue dictating. If we are done writing on the board, let me know so we can continue dictating. Emmanuel, Genesis, thank you. Yes. Megan Clem said done. Yes, let me see more done. Let me see more done. Let me see more done. Peculiar said done. Mercy Bamdele said yes. Peculiar said continue. Michael said I'm done. Yes. I've noticed the top commenters on this live. Well done, well done. Always supporting, always like drop at least. Ah, well done, yes. Someone said, what of X, sir? Where do you see X? Dawn. Delight said Dawn. Yes, good luck, Kanu. Alex wrote to me, said, yes, sir. Okay. Yes, yes. So right now, have you written down law of conservation of linear momentum? Have you written down law of conservation of linear momentum? Okay, let's go now. Law of conservation of linear momentum, are you there? States that law of conservation of linear momentum states that the total linear momentum. Law of conservation of linear momentum states that the total linear momentum of a system is constant. Law of conservation of linear momentum states that the total linear momentum of a system is constant. Law of conservation of linear momentum states that the total linear momentum of a system is what? Is constant. That is, continue writing, that is, so I said law of conservation of linear momentum states that the total linear momentum of a system is what? Is constant. That is, the total momentum before collision equals total momentum after collision. That is, total momentum before collision equals total momentum after collision. The law of conservation of linear momentum, the law of conservation of linear momentum, the law of conservation of linear momentum states that the total momentum of a system is a constant. The total momentum of a system is a constant. That is, the total momentum before collision is equal to total momentum after collision. See how the class is going smoothly? Imagine we'll cover this like chemistry, cover this like math, like this. Before January is over, say, with this, if you are consistent and you are serious and you don't slack, you see how we cover your syllabus very fast. Then they give an assignment, no problem. We'll just solve your assignment easily. We just come to the board, pieces your assignment easily. Now let's go. Total momentum is a what? Constant. Total momentum before collision equals total momentum after collision. Let's now go and explain it on the board. Let's go and explain it on the board. So I've written it down. Let's go and explain it on the board. Yes. So class, to explain the law of conservation of linear momentum, what that law means is that when we resolve these two bodies' total momentum before they collided, it will be the same if we resolve these two bodies' total momentum after they collided. I mean, there is no change in the total momentum. Class, there might be change in momentum of each of the body. But by the time you solve the two of them's momentum, the total momentum here is still equal to total momentum here. What this means simply means is that total momentum before collision, which is initial momentum, must be equal to total final momentum. Remember that P is the symbol for momentum. P is the symbol for what? Momentum. P is the symbol for momentum. P is the symbol for momentum. So total momentum before collision. What is the formula for momentum, class? Mass times velocity. So m1u1. Now class, another thing that used to confuse students in this aspect of physics. When do we use plus or when do we use minus? I'm going to say m1u1 plus or minus m2, because these people have their masses. These two bodies have their masses. So m1 means mass of the first body, m2 means mass of the second body, u1 means initial velocity of the first body, u2 means initial velocity of the second body. We're going to say m1 times u1 because momentum is mass times velocity. So mass of this body times velocity of this body plus or minus mass of this body m2 times velocity of this body u2 must be equal to, after collision now, mass of this body m1 times velocity of this body v1 plus or minus mass of this body m2 times velocity of this body v2. I know why I put plus or minus class. But class, your question, let me tell you, this part of physics is one aspect of physics that does not have one fixed formula. It depends on how these two bodies are moving to each other, class. If these bodies are moving in opposite direction to each other, class, this is what you will do. If these two bodies are moving in the same direction before they collided, class, you know that this illustration is different from this illustration. In this illustration, they were moving in the same direction. But in this illustration, they were moving in opposite direction. In this illustration, since they are moving in the same direction, they are both positive. So they are moving in the positive direction. So we are going to use plus. We're going to use what? For this, if the two bodies before collision, they were moving like this. We're going to use plus. Then again, after collision, how are they moving? Are they still moving like this? Or they are now moving like this? Class, if they are moving still like this, it means it's still plus. It means that this is the formula that will work. M1U1 plus M2U2 equals to M1V1 plus M2V2. But class, if you are told that one of the bodies is now moving in opposite direction, that body is one that will carry minus, and the other person will carry plus. So they will tell you one of the bodies now moving in opposite direction. That opposite means minus. You give the person minus. If they told you that the second body now moves in opposite direction, minus, then this guy is still plus. So who is the minus 2, right? That is the second body, M2V2. The first body is M1V1. This is after collision. I'm talking about after. So like this before collision. So these two bodies were moving like this before collision. After collision, this now happened. This guy is now minus, this guy is now plus. So this way M1V1 minus M2V2. There are different scenarios. There are different what? Scenarios. That's why we see the formula will put plus or minus. So the question determines how the solution will be. Now look at this. These two guys are moving in opposite direction. Before collision, they're moving in opposite direction. Class, this guy is moving in the positive x-axis, so this is plus. Which guy is coming in negative x-axis, this is what? Minus. So this is going to be, before collision, the solution of this is M1U1, so this is plus, because M1U1 minus M2U2, because this guy is coming in opposite x direction. So before collision, M1U1 minus M2U2 equals to, after collision, let us say they are not moving in the same direction. M1V1, if they are moving in the same direction, it's positive. Equals to M1V1 plus M2V2. But if they are moving in opposite direction, your negative must come in. I want to get a class. So this is one aspect of physics. I decided to teach this topic today because it's one aspect of physics that you don't have one formula fits all. Now, class, are you aware that everything I've been doing so far is for elastic collision? All these formulas are for elastic collision. Do you know why? Who remembers that for elastic collision, the two bodies after collision do not stick together, they move with different velocity. Class, anything that makes you to still have V1 and V2 different velocity after collision, just know that that collision is elastic. That means they do not stick together. Because let me tell you, there's only one common formula for when the bodies stick together after collision. After collision, class, if they stop together after collision, they will have the same velocity. So, I didn't mean they stop together after collision, class, it will have been M1V plus M2V. We're not going to call it V1 and V2 because the two V's are the same, they move with the same velocity. But the masses are still different. You can say M1, M2. Let us bring out V, and we're going to have V into bracket what? M1. Bring out V from here, what will remain in M1? Bring out V from here, what will remain in M2? Class, this is always going to be the formula after collision. If they stick together. If they told you that the body sticks together with common velocity, you don't need to be bothered about all these plus or minus things after collision because this is correct. There's no minus after collision. If they stick together, if they stick, class, doesn't mean that they cannot be minus before they collided. Class, if these two bodies collided in opposite direction like this, this is what's going to happen. So the M1U1 minus M2U2, M1U1 minus M2U2 equals to V into bracket M1 plus M2. M1U1 minus M2U2 equals to V into bracket M1 plus M2. So before collision, you see that it's still minus. But after collision, class, whether it is elastic or inelastic, after collision, this formula always holds. After collision, this formula always holds. Before I go too far, I will come back to the screen and let me interact with you. Are we still following? If you have any question, you can drop it in the comment. Let me come back now and interact with you a bit. I don't want you to be too lost. Good. We still have 53 people in the class. Well done. This is very good. This is encouraging. 53 people in the class. So class, what do you think? What do you think? Any questions? Any questions? Drop your comment. Any questions? Before I proceed, I want to start taking examples. Question like live questions that will. Okay, Michael Oberisike said, sir, please recap a bit. Good. You see, so we can interact in the live class. We are interacting like this. Who else? Any other questions? Is that your only question? Sir, please explain. Emmanuel said 100. That means you understand. Okay, good. But good luck says, sir, please explain. Michael Azubike said, sir, I don't understand. I will come again. I will come again. Good. Thank God I came back. If not, I will just continue teaching like that. Good. Any other questions? Sir, please. I'm looking for specific questions. Yeah, please come again. Okay, everybody's just saying come again. So let's just go and come again. Okay, Peculiar said continue. That means she understand. Alex wrote to me, says, sir, please recap small. Next gen says, sir, explain again. Lawrence says, so sir, with this formula, we can solve any problem related to this. Which formula? Because I didn't give there's not one specific formula. Please, is this sign before or after collision? Is the sign before or after collision? Which of the signs? Which of the signs are you talking about? Let me see if there was any question before I came, when I was teaching on the board. Let me scroll up. Yes, someone says, so sir, the direction of the arrow determines the sign either positive or negative. Yes. So sir, the direction of the arrow determines the sign either positive or negative. Okay, I have an idea, class. Anytime I'm teaching on the board, already drop your comments. If you have any questions, drop your questions. So when I come, I don't need to be asking any questions, so we'll not be slow. I'll just be scrolling up. Do you understand? Does it make sense? I'll be scrolling up to see the questions, so you will not be start wasting time. Say, ask your questions. So while I'm teaching on the board, be dropping your questions already. So anytime I come here to flip the camera to my side, I'll just be flipping like this. I'll be scrolling like this. Like I'm checking my screen. I'm saying questions you have asked before. Someone says, so sir, this formula, we can solve any problem with relating to this. Yes, if you understand the formula well. Someone says, sir, please, is the sign before or after collision? Which of them? How will you know which particular body is going the opposite direction? They will tell you. Marvelous said, how will you know which particular body is going the direction? They will tell you. They will say, given that the second body moves in opposite direction, or given that the first body moves in opposite direction, they will tell you. Smart question, yes. Sir, what if the arrow points to the left side? Which of the arrow? If the arrow points to the left side, okay, let me give you a rule. If the arrow points to the left side, that is negative. If the arrow points to the right side, it's positive. Let me check more questions. This is good ahead. So while I was teaching, some people were dropping questions. So when I come and flip the camera to my side, what I need to do is just to check for questions you have asked. So I'm not wasting my time saying, drop your question. It takes time. Do you get? Let's try and minimize the time, eh? Yes. We're still getting used to this life. So by the time we perfect it, you see that we'll just be understanding each other. So now we have found out something today that we can flip the camera and be talking with you, ask your questions. I will be checking your question one after the other. Do you get? And I'll go and explain on the board. I can explain what is we are not understanding exactly. Yes. So the M1V1 minus M2V2 equals to VM1M2. This is what I was talking about. Okay, Lawrence, this is what I'm talking about. Yes. The minus before collision is attached to the M2. Second body, because it's the second body that is moving in what? In the left axis. Check the arrow. See, the second body is one moving in the left axis. So the equation with the same velocity is for what? It's for when they are moving in, when they stick together after collision. When they stick together after collision with the same velocity, that's what that equation is for. That is for inelastic collision. It's for inelastic collision. Any other question? Let me see. Okay, Uzoma says, sir, please just recap. I'll just go back and recap again. Sir, is it in inelastic collision that the velocity is common? Yes. It is. David said, sir, is it in inelastic collision that the velocity is common? Yes. It is in inelastic collision. Check your notes now. It is in inelastic collision that the velocity is what? Common. Okay. Lawrence says, okay, sir, I've got it now. Good. Good ahead. It means that we are following. Zena says, sir, the equation with the same velocity is for what? The equation with the same velocity is for inelastic collision. When they stick together after collision, it's inelastic collision. Any other questions? I think I've answered all the questions now. So I wasn't in school today. Was this taught in a physical class today? No. Today, what we did in physical class? What did we do in physical class today? Okay, we did a question on what they call it. I've forgotten. We did question on what did we do in class today? Elevator system, elevator lift system. We did question on recoil velocity, recoil speed of a gun, which I've already taught in the online class. So please, all our previous online class, if this is your first time of attending our online class, go to my channel and check my live class. You will see all the live classes we're having so far. You can still watch them, even if you're not around then. You maybe you're in the village and your net was very bad. You can go and watch it again. Do you understand? Okay, I am making this and say, sir, let's proceed. Sir, let's proceed. Okay, let's go back to the board and let us proceed. The board now. Okay. Let us take our first question for the day. Oh, I was supposed to take questions. Let me give you our first question for the day. When we take our first question for the day, it will help you to understand the collision better. Are we together? Let's take our first question for the day. A ball of mass 5 kg. A ball of mass 5 kg. A ball of mass 5 kg A ball of mass 5 kg. Write this question down. A ball of mass 5 kg. A ball of mass 5 kg. No matter how I explain this thing, you will not understand until I take question. Let me use one question to explain it. Are we together? Let me use question to explain it. I'm coming again with question. Instead of going back to resolve an hypothetical equation that you'll still be confused. Why not let me take a question that will explain it better? A ball of mass 5 kg. Moving with a velocity of 4 meters per second. Moving with a velocity of 4 meters per second. A ball of mass 5 kg. Moving with a velocity of 4 meters per second. Collides with another ball of mass 10 kg. Collides with another ball of mass 10 kg. Collides with another ball of mass 10 kg. Moving with a velocity of 1 meter per second in opposite direction. Moving with a velocity of 1 meter per second in opposite direction. Moving with a velocity of 1 meter per second in opposite direction. If the both balls stick together after collision, calculate their common velocity. If the both balls stick together after collision, calculate their common velocity. If the both balls stick together after collision, calculate their common velocity. Another question. A 4 kg moving at 8 meters per second. Moving at 8 meters per second. A 4 kg ball moving at 8 meters per second collides with a stationary ball. Collides with a stationary ball. Collides with a stationary ball of mass 12 kg. Collides with a stationary ball of mass 12 kg. And they stick together. Someone says, please come again. Let me come again with the question. A 4 kg ball moving at 8 meters per second. I believe you got the first question, Abi. That one is not a problem. Everybody has gotten the first question, Abi. So we're in second question. A 4 kg ball moving at 8 meters per second collides with a stationary ball of mass 12 kg. A 4 kg ball moving at 8 meters per second collides with a stationary ball of mass 12 kg. And they stick together. Calculate the final velocity. Calculate the final velocity and the kinetic energy lost in the impact. Calculate the final velocity and the kinetic energy lost in the impact. Calculate the final velocity and the kinetic energy lost in the impact. Calculate the final velocity and the kinetic energy lost in the impact. Blessing Chibiko says, sir, please come again. Okay, let me come again. A 4 kg ball moving at 8 meters per second. A 4 kg ball moving at 8 meters per second collides with a stationary ball. Collides with a stationary ball of mass 12 kg. And they stick together. Collides with a stationary ball of mass 12 kg. And they stick together. Calculate the final velocity and the kinetic energy lost on impact. Calculate the final velocity and the kinetic energy lost on impact. Calculate the final velocity and the kinetic energy lost on impact. So can we go and solve now? Lawrence says, sir, please come again with the first question. First question said, a ball of mass 5 kg. Let's go with the first question again. People are saying, sir, the first question, the first example. Sir, I can't hear you. Let me come again. I'm coming again. Number one, first question. Let's go again. Everybody saying first question. Let's go again. A ball of mass 5 kg. A ball of mass 5 kg. Oh, someone says, sir, don't be fast. Why irritating? Gently, sir. Okay. A ball of mass 5 kg. A ball of mass 5 kg. Moving with a velocity of 4 meters per second. Moving with a velocity of 4 meters per second. Moving with a velocity of 4 meters per second. Collides with another ball of mass 10 kg. Collides with another ball of mass 10 kg. Collides with another ball of mass 10 kg. Moving with a velocity of 1 meter per second. Moving with a velocity of 1 meter per second. in opposite direction. So you see, who is in opposite direction? The second ball is in opposite. The second ball is in what? Opposite direction. If they both stick together after collision, if they both stick together after collision, if they both stick together after collision, calculate their common velocity, calculate their common velocity. If they both stick together after collision, calculate their common velocity, calculate their common velocity. Have you gotten the both questions? Now please drop your comments, drop your comments. Have you gotten the both questions? Do we have any smart students that have already started solving before I even solve? Let me see, let's encourage let's encourage intelligence a bit. But if you have gotten the two questions, let me see, drop your comments. If you have gotten the two questions, drop your comments. If you have gotten the two questions, drop so I can go and solve on the board. You've gotten the two questions, drop your comments so I can go and solve on the board. Delight said yes, we have gotten it. Okay, who else? You have gotten the two questions. Someone says, sir, I did not give mass for M2 in number 1. I gave mass now. A ball of mass 5 kg moving with a velocity of 4 meters per second collides with another ball of mass 10 kg, collides with another ball of mass 10 kg, moving with a velocity of 1 meter per second in opposite direction, So the mass of the first body is 5 kg, mass of the second body is 10 kg. If they both stick together after collision, calculate their common velocity. Let us go to the board and go and solve. If we solve these two questions, we are done for the day. If we solve these two questions, we are done for the day. So if you always have problem reading in the night, you always have problem studying. I think this online class will help you to, at least you are sure you're learning 1 hour every night. So the day you do not read, you know that you not feel too bad. I've learned 1 hour. You understand? So if sometimes you are pressing your phone on TikTok and you have not read, you're feeling guilty as a student. I used to have that guilt. I press phone and I have exam. I just enter school and I'm pressing phone. At least anytime you know, I've learned 1 hour. I've learned 1 hour in class. And at least every day I'm going to be learning 1 hour. Whether I'm serious or not, whether I read my book or not, every day I'm learning 1 hour. It's not bad. It's not a bad thing. So this will help you. Keep you on your toes, your studies, help you to be studying. Remind you why you should be studying. Now, a ball of mass, let's do the, which one? Okay, a ball of mass, let's do the first question. A ball of mass, 5 kg. So you're going to say 5 kg. In order to solve the question, well, you must be able to illustrate what is happening. So a ball of mass, 5 kg. So M1 is 5 kg. Moving with a velocity, so U1 is 4 meters per second. Collides with another ball of mass 10 kg. Collides with another ball of mass 10 kg. Second ball, M2, is 10 kg. Moving with a velocity U2 is 1 meter per second. After collision, they stick together. Class, if they stick together after collision, this is what happens when two bodies stick together after collision. They stick together. So this M1, this M2, and they will have the same velocity V. They will not be V1 and V2, no, because they have the same velocity. If they are sticking together, two bodies moving together have the same velocity. Do you know if you're in a car? Do you know if you're inside the car, you're sitting inside the car? Your velocity is the velocity of the car. If the car is moving at 20 meters per second, you are also moving at 20 meters per second. Because you are inside the car, you are stuck in the car. So the speed of the car is also your speed. This is what leads to accident on the road. Are we together? Because you cannot control the speed. The car is the one that is determining your life at that point. The speed of the person is also your speed. You cannot control it. Meanwhile, you're not running, but the car is running, so it's carrying you with it. This is the common velocity class. Anytime they stick together after collision, let us first resolve what happened before collision. A ball of mass 5 kg, right? Moving with a velocity of 4 meters per second. So moving is moving. Class, anytime they say body is moving, always assume positive. It's moving in the positive direction. It's moving, right? This guy has started moving positive. Now collides with another ball of mass 10 kg, moving with a velocity of 1 meter per second, moving in opposite, so gives it the opposite. Class, in opposite. This is the arrow, opposite. And if they say moving in the same direction, to both of them will be positive, positive. Do you get? Both of them will be positive, positive, but moving in opposite direction. Because this guy is opposite, it means that this guy is automatically negative. So this was going to be M1U1, watch, M1U1 minus, because this guy is kind of negative, coming opposite, minus M2U2 equals to, class, anytime two bodies stick together after collision, they stick together, right? It's going to be V into bracket. Just note this, M1 plus M2. Anytime they stick together after collision, V into bracket M1 plus M2. This is the formula for after collision. Before collision, this is not a constant formula because when they move in the same direction, if they were moving two of them in the same direction, it would have been plus. If they were going in the same direction, but they are going in the opposite direction, is what? Minus. Who is the minus attached to? To the second body that is coming in the opposite direction. Note, the minus is not attached to this body, it's attached to the second body. This is the formula we're going to use, and this is what they're asking us to find. What is their common velocity after collision? What is their common velocity? V. After this, is what we're looking for, V. So that once you can analyze it like this, your solving becomes very easy. What's M1? Our M1 is 5. What's our U1? Our U1 is 4. Minus, what's our M2? Our M2 is 10. What's our U2? Our U2 is 1. Equals to V into bracket. What is M1? 5 kg. What's M2? 10 kg. 5 times 4, 20. Minus 10 times 1, 10. Equals to V into bracket 5 plus 10, 15. 20 minus 10 is 10. So 10 equals to V times 15, 15 V. Divide both sides by 15. So that V equals to 10 all over 15. 5 here, 2, 5 here, 3. 2 divided by 3 should give you 0.666, approximately 0.67 meter per seconds. Do you see how this example helps me to explain it very well? And even I came here to start explaining that formula, so I come again, I've explained entire, no evidence. I've explained entire, but now I have evidence. So using the question, sometimes when students say they don't understand the formula, don't bother going back to the formula because there's no application. It will not make sense until you give a question that formula can attack. So that you can, okay, this is what it's trying to say. Oh, so this is what this arrow means. So what is the opposite direction? Okay, that's why I gave this guy minus. Okay. Oh, they move together with the same velocity. They stick together after collision. Okay, that's why they're having V, or they're having only one velocity. You see, I even join M1, they are sticking together. The two masses after collision are sticking M1 plus M. So this is the common velocity. Class, this is the question. That second question will be like an assignment. Class, that second question will be like an assignment. We're going to use that second question as an assignment. This is already almost 11. We have school tomorrow. Yeah, someone said perfectly understood. That's good. We have school tomorrow. So me too, I have class tomorrow. I have driving school tomorrow. So that second question, let's take it as an assignment. Do we agree? The second question should be an assignment. So we have something we are continuing with in the next class. I hope we have actually understood today's class. I hope we enjoyed today's class. First timers, I hope you can see. Hope you understood today's class. Yeah, let's do our last comment before we go. Are we still there? Yes, Amechi, thank you. Said wonderful. Yes. Amechi decency. Well done. Yes. Michael. So you see, everybody's now understanding it after I've used the question now, right? Yes. Okay, someone said repeat the second question because that's the assignment. In case you didn't get the second question, let me repeat it again. It's an assignment for our next class. Yes. Ekime said understood. Yes, thank you, sir. OTJ Ketnet said thank you. The best. Thank you. Yes, sir. Yes. Delight. Yes. Everybody, mercy. Yes. Let me repeat the second question because that's your assignment for the next class. Very good class. Thank you very much. Please don't forget to message us, sir. Let me join. If you've not registered with us, it will be difficult to continue this class like this. Do you understand? It's not easy. But if you know you like this, you've seen what you are paying for, Abi, message us. Support us. It's not easy every night. See, 11 a.m., 11 p.m. I'm supposed to be sleeping. Please message us. You've not registered so that very soon we might now start separating those that have not registered. We might start separating those that have not registered. Please, if you've not registered for the class, send me a message. I dropped my WhatsApp number earlier, 081-824-24350. Join this online class. You cannot fail. If you should be seeing it yourself, this class I will pass. No worry. If I continue learning like this every day till exam, I go pass. Sure. Yes. Someone say, hope I can replay. I already slept off. Yes, you can replay. The good thing about this class is that as I'm recording it, it's uploading live to my channel straight. So you can always replay. Someone said dictate the assignment so that that will be the second question for the assignment. Let me dictate again. A 4 kg ball moving at 8 meters per second collides with a stationary ball of mass 12 kg. A 4 kg ball, thank you. Ebukawan says, how you did try? Thank you, thank you, thank you. Adeyoju say, yes, we agree. Yes, thank you very much. Thank you very much. So please don't forget to message me if you're not registered. Support us. You might not have all the money. Me, I understand. I was a student like you. Let me tell you, when I was going for the tutor, when I was in year 1, back then when I was in school, I was paying small. My teacher allowed me, but you saw my passion that I wanted to learn. I was paying small, and they allowed me. So you want to start class? Let me just start. Some people have joined us. Let me just start with this one. I want to join you. I like your class. Message us. No, department doesn't matter. No matter your department, you can join us. No matter your department. Thank you. Fantastic job, sir. Thank you, sir. Well done. Yes. So I was taking the assignment. A 4 kg ball moving at 8 meters per second collides with a stationary ball. A 4 kg ball moving at 8 meters per second collides with a stationary ball of mass 12 kg. Collides with a stationary ball of mass 12 kg. And they stick together. Calculate the final velocity and the kinetic energy lost on impact. Calculate the final velocity and the kinetic energy lost on impact. If you have not subscribed to our channel, please, before you go, subscribe to our channel. So that when we come on live, you will know. Just hit the subscribe button. It's not much. When they subscribe, I think it's money you're paying. You're not paying. You just subscribe. Like to follow me. Like I say, follow me on Instagram. Just hit the subscribe button. Are we together? If you have anybody writing JAM, direct them to us. I have their online class like this for JAM too. JAM students. Before I came to teach you now, I taught JAM this evening. I did a small JAM class this evening before I came to teach you. So I've done 2 classes this night. I've done JAM class this night. And I'm teaching you now. Are we together? So when I see students say they are tired, I say, hey, you know my own schedule, I work. Why are you tired? And you are younger than me. You have more energy yourself. Hey, as a young person saying they are tired. When you come grow old now, which energy you now have? You already tired as a young boy or young girl. So please, let's sit up. Sit up. Discipline yourself. You discipline yourself. Some of you should learn from us. You know, I see man is still teaching, doing this. He thought this, he thought that, and he's not tired. So why are you tired? You as a young person. Are we together? So those, if you have anybody that is writing JAM, you have any junior brother, junior sister that is writing JAM, direct them to us. I have an online class like this for JAM too. Are we together? This one is my year 1 class, but I have something like this for JAM. I taught JAM today. You have a junior brother, no matter where they are, you can teach them online. No, so the distance is not a barrier, even if they're science or art students. I have a group for art students JAM. I have a group for science students JAM. Yes. So you have anybody writing JAM, please refer them to us. Refer them to us. Yes. And then you just said, okay, me, I don't get money, but you know that very soon, if you've not paid, only those that have registered will be added to the live class. So please, when there's a way, there's a way. Are we together? Don't always go with you don't have money, you don't understand. Yes. Someone said, no be like this university there for film. Abi, don't be like this university there for film. When we are watching movies, the university is always looking so lively, right? So lively, everything is looking good, but in real life, it's not like that. Yes, guys. So, class, tomorrow we have chemistry in our physical class by 10 o'clock. Yes, 10 to 12 is chemistry in our physical class at 3.7 in 1. Also, I forgot, if you need this exam question, past exam question, you will not see this anywhere. This is your lecturer's secret to what you will set in the exam. You will not see this anywhere. Lecturers don't like you to have this. I already mentioned this in our physical class today. If you're not in our physical class, let me tell you one thing. Ask your sister or your brother or your friend. If you have anybody in year 1, ask them what happened during your exam, your year 1 exam. Ask them what happened. During your year 1 exam, what happened? After everybody finished writing exam, lecturer came and collect everybody's question paper from everybody. They are going to sit you down and collect your question paper from you, all of you. The question is why? Why are they hiding that question? Any school that hides their past exam question, just know that they can repeat it again. Uniport is one school that repeats exam questions a lot. I want to give you a test. Now, anybody that has this past question, although it's a risky test, take this person to your lecture tomorrow morning. Let your lecturer see. Put it in front of him. He will seize it. I'm giving you this test. Just put this in front of him. It happens every year. They will seize this question. Why? Because they don't want you to have this. Because sometimes, very close to exam, lecturers are so busy. They don't have time to set new questions. They will just go to 3-4 years ago, mix the questions up together. In their mind, you were not here 3 years ago, so there's no way you have that question in your hand. You were not in Uniport 4 years ago. There's no way you have that question in your hand. So if I'm a lecturer, I can go and mix my last 5 years question, mix it with last 2 years, and set again. You will be seeing it as a new question, but someone that has seen past question will be enjoying in the exam. Or This school is about update. This school works with update. Now update. This school now updates. So in this person, I've compiled all the Uniport exam questions for several years, and I solved them myself. The way I teach is the way I solve my past questions, so that you can understand very well. So you need the exam past question. You can message me. It's a combined past question. Are we together? Before, this past question used to be very, very expensive, because before I used to sell it each course by course. Do you understand? I used to sell it 2,000 per course. 2,000. If you want from chemistry, 2,000. Mathematics, Math 110, 2,000. Math 120, 2,000. GS, 2,000. But if you are doing 8 courses, 2,000 times 8 is how much? 16,000. It's so expensive. But now I say, okay, some people now say, sir, please, can we combine it together? Can we combine the past question into one book and make it cheaper? Yes. So instead of paying 2,000 per course for each course, because people were rushing it, they say, is this an important exam question? I say, yes. So people went to go and ask their brother in year 1, is this what you wrote last year? Yes. I'm challenging you now. If you have a past question, go to your sister in year 1 or your brother in year 1 and ask them, is this what you wrote last year? Are we together? Is this what you wrote last year in the exam? If they say no, bring the question back, I failed you. I'm challenging you to go and do that. This is the exam you wrote last year. If you don't have this person and you enter the exam, or someone that has this book, you'll be smiling, because there are some questions that must be repeated, sure. Now, while you are solving that question as a new question, someone has seen it before, you just pick answer, say, hey, they solve, they solve. That's why some people finish first before some people. Why? Because they have seen some questions before. Yes, someone says, GS inside, GS is inside. FSB is inside. Engine drawing is inside for engine drawing students. Everything is inside. I combined it. And it's not just 1 year, it's not 2 years, not 3 years. 4 or 5 years of exam, Uniport lecturer's exam question. You see what the lecturer can set for you in the exam. If you need this past question, message me now on WhatsApp. It's 5,500. It's 5,005. It's cheaper than most of your textbooks that you're buying. This guy will help you than all the textbooks you buy in this school. This guy. They will be deceiving you with simple example in your textbook. This is where exam is coming from. And as a lecturer will seize it. If he sees it in your hand in class, he's going to seize it from you. So I don't want to make this video too long. If you need this past question, I don't need to talk too much. The one that I brought today in class, they finished it. Every day I come to class, they finish it. All the person I brought today in the physical class, they finished it. In fact, I'm even owing some people past question. That's how serious it is. I don't know who is telling them. Maybe their senior colleagues are telling them, go get past question or go get... who is telling you guys? Because it's like, I'm not even the one talking again. People are just getting it. All the ones I brought to class, they finished it. So I'm even producing more now. This one is the one I have in my house. Are we together? So see you guys tomorrow. By tomorrow, we don't have online class tomorrow. We have physical class tomorrow. Yes. Hope you saw our timetable. If you came late, so rewind the video to the beginning. You see where I put the timetable for the online class. So Monday is going to be for physics. Wednesday is for Math 120. Thursday is for Math 110. Saturday is for assignments. Are we together? Then chemistry online class will either come in on Tuesday or on Friday. Mr. Desi will be the one handling chemistry. We will revert to you. Are we together? So message me. You need the past exam question. Message me now on WhatsApp 081-824-24350. You want to register for our online class? So let me drop something. You did try. Show me small love, so that I feel smile, go sleep this night. Show me small love. So just message me on WhatsApp. So please send the account. Let me be paying small. How much is your online class? Let me be paying small. I want to join this class. Or let me just pay everything. Anyone. We are ready. We are ready. All right, good night, everybody. Have a good night. See you tomorrow in our physical class, 10 o'clock. We're doing chemistry tomorrow, 10 o'clock at 3.7 If you're not offering chemistry, no problem. But if you're offering chemistry, join us tomorrow by 10 a.m. 3.7 Chemistry class live, 10 a.m. at 3.7 auditorium. Bye-bye. Good night. Thank you very much. Good night, yes. Bamidele Messi said good night, yes. Lawrence, good night, yes. Thank you. Let me not be as I'm not replying. Any good night. Anybody that's saying good night too. Thank you. Good night. Yeah, Dina said thank you very much, sir. God bless you. Thank you. Alex wrote to me, said good night. Yes. Kelvin said I have a question. Me, where don't they go bed like this? Kelvin, where's your question? Can I quickly answer it? Kelvin Dapper, what's your question? Kelvin said I have a question. Message me on WhatsApp, Kelvin. Message me on WhatsApp. Message me on WhatsApp, Kelvin. Yes. Okay, good night, everybody. Good night. See you in class 10 a.m. chemistry. 3.7 Thank you. Goodbye. Bye.